EPROM9 doing another video. Who'd have thought? So quickly, so soon. What's going on? Yes, look at this. Oh, for God's sake, look at that. Go straight into play. There we go. Oh, damn it. But that is the output of a logic analyzer. Why? Because a cheapy logic analyzer comes into post, which is basically a clone of one and uses the same chipset as a $200 and something, which if you convert that into UK is going to be at least 100 and something quid. So yeah, and what you really get out of it is a fancy case. What you're truly paying for is the software. Whee! So bonus, because the software is free on their website. I'll stick a link in if I remember. But that's not the subject of logic probes. The subject is what I've done with it. And what I've done with it, everyone remembers this board. Bear with me, the fluoro's got to warm up. I've just switched it on. The MP4 player circuit board that I had hooked up to the Pi and was reading data on the serial port. Well, we've made some more progress. Using this, we have been able to find out things like baud rates, although I'm still yet to hook it up to the Pi. But if we read through this, and the camera hopefully will stay focused for us, in mode 1, which is also the I've got the thing here that I've written, TV out mode, is you switch it on in that, default CMD boot auto. Press enter before countdown expires to intercept, and then there's a tiny whittle of data hiding over here. Now I haven't got much room for my mouse with my soldering iron. And we get a nice little whittle of 2R/R/N, so good old ASCII. So that's what we get out of that output. The second output we get, which is the IDE statistics, and the second position of the switch is IDE waiting for drives to settle. So that's basically giving IDE status information, because there's technically about 2 IDE devices which actually go in the thing. There's compact flash, which uses the same protocol as IDE, and there's also the hard drive itself, which is a standard IDE header pin. And then this, which surprised me, I2C packets. Now we've got 2 points. There's this little dimple of information up here, but there seems to be nothing amazingly significant about it, other than it's got some really short rise times. You know, you're looking at that, you're looking at 12.375 USECs between that and this one is 0.375 USECs. This is incredibly fast data right there. Okay, I'll be down. And if we go back, we have our I2C, which, looking at that, because I've done a networking course, I sort of see a packet we've got set up right to acknowledge, 0 to acknowledge. This is all about the packet communication. The interesting thing is we have loads of these 0+ acknowledges, but the points of data only seem to be 0, so I'm wondering whether it's expecting something back from the I2C for whatever it's connected to, and it's not receiving anything, so inevitably it times out and then the logic probe stops capturing. Then it's sending out a sort of hello, are you there, and using essentially a TCP type protocol. But we'll move on to the Raspberry Pi once I've eaten. As a typical EEPROM thing to do, forget to show you the baud rate it's calculated. This thing's brilliant, and for about 8 quid off eBay it's a thumbs up and a definite buy. Works a treat. The weird and wonderful baud rate entered into the Pi. Let's see what happens. Now I'm going to do this open like this, so it's not ideal. Open. Find the power button. and enter. Hit enter. Now, interestingly, while it came up on the logic analyzer in stuff that made sense, it's still coming up as complete jargon on the Raspberry Pi, which is a very interesting note. Weird. I'm a bit lost on options here. Put the right baud rate in, the settings are correct, and yet we still have nothing. Weird. I'll look into that, bear with me. Might be worth trying connecting it up to something other than a Raspberry Pi. Problem is, that's the only thing I have that can communicate on those levels. Bit of a problem, isn't it? I'll see what I can do. Might as well. Several other attempts to get the Pi to read the serial were all unsuccessful. So let's just take a closer look at the PCB instead. Here we have the main DSP processor chip, complete with its own RAM. This is basically your do-everything dog microprocessor. In fact, there's functionality for hooking up to cameras, so it's a sort of very generic IC that you'd hook up to that you'd use in digital cameras, which had extra functionality because it's got the ability to connect to CF cards, SD cards, trans cards, whatever cards you can think of. Here we have an Altera Cyclone FPGA, which is, I have a dev board still have it, with the Cyclone 3. I will have to do some playing with that at one point. Here we have a little NEC. I haven't put any research into what that does. These two chips don't look like anything specific other than sort of line logic buffers, which look like, yeah, they link to the IDE channel, so that's probably some driver buffers for the IDE channels. You got your standard IR remote control, plenty of little mini switch mode circuits around the switch here, which coincidentally is the opposite side of the board to the power connector there. Then you have your headphone out and whatnot, power input. This does not charge over USB, although it does have USB functionality. This is your power switch. These are just generic switches, probably going to be linked to GPIO either on this or this. Then you've got some nice little tactile buttons which you can push down and you can move them sideways, and another bit just broke off of it because, you know, you got to build these things out of the highest quality plastic, of course. Interesting to note as well as a serial header I've been doing, which, as we've discovered today, does not just standard serial but also I2C, so it might be worth probing the I2C at a later date. I can't really be bothered to set up the Pi to do it tonight. Then there's this, which could be another interface connector, could be a JTAG. That looks like a JTAG there, but I'm not 100% sure. Could be another connector to probe for a later date. Same with this. This will be your USB interface chip. I mean, if you look there, it looks like you've got a differential pair going right there into the USB connector. If we flip the board over, we have our LCD display connector. We have what looks to be some kind of RAM, SD RAM of some type, probably for one of the other processors, maybe extra memory for the FPGA. You've got some more, just looks like standard sort of buffery type chips, also one here. We have this Philips SAA7115HL chip. This looks like another type of controller because right next to it is a little crystal oscillator, same with here. You've got a little 8-pin package up here. Difficult to really see what that is. But somewhere on here there'd be an I2C, probably for either the processor FPG. I'd imagine the I2C would be for this, the main processor. I don't see any direct I2C chips, but to be honest, I haven't looked. And this is your main flash, which is your ROM. It might be worth trying to find a way to interface into this and actually read the program data. See what we can extract out and maybe reverse engineer the software side of this thing. This is your IDE connector for your standard mechanical laptop hard drive. And really that's just about it. More power regulation. There's quite a lot of power regulation on this board. More power regulation here. Plenty of decoupling caps. This side is relatively basic, simple, and not amazingly interesting. This is the interesting side. But yeah, not much else to it. Here's a big old inductor, which is definitely power. I mean, this is going to have a number of step up and step down converters because it's got to operate 5 volts, 3.3 volts, 1 point something volts for the cores, 18 volts for the LCD backlight. I do know that, I tested it, and I've even got it so I can run the LCD backlight outside. I'm going to make some interesting little lighting fixture. But apart from that, thanks for watching. Hope this was interesting.